Alexa, prepare me a Fernet. In this video, I'll demonstrate how I built an Alexa-powered refrigerator that mixes drinks and makes cocktails. I've wanted to do a project like this for a long time, but honestly, I couldn't quite figure out how. Several like this one currently exist, preparing drinks and working like a conveyor belt or small piece of furniture. The glass positions itself under the bottles and dispenses the drinks in their exact proportion. But I wanted the bottles to be hidden. I didn't want it to look like a bar. And also something very important, I wanted the drinks to be cold. Otherwise, I didn't see much point in it. After thinking, I knew that the most important thing was to start with the fridge itself. It couldn't be too big because I also wanted it to look like a small table. I got this mini bar on Facebook for only about $30. It was quite worn out, but it worked well. The sheet metal was unsightly, but I wouldn't leave it in that state. Let's restore it. First of all, I choose everything to remove all the rust using a grinder and my Dremel. But before that, I wanted to talk to you for a second about Odoo. I wasn't too concerned about the final result since it wouldn't be visible. I applied a coat of anti-rust spray to stop it from rusting again, also to prevent the existing rust from spreading. Then I started cutting some wood, in this case a 15mm pine board. Honestly, I bought something cheap since it was going to be painted anyway. The plank had rounded edges. I just took it off with the saw. I also took the opportunity to clean up the hillside, which was pretty ugly. I glued the woods on the hillside using a universal glue. And to make it more fixed, I put a couple of screws that I later covered with white putty. A tip when using white filler is you can mix it with a little plaster and it becomes thicker. Do you remember the rounded edges I removed? I recycled the semicircles and glued them to the front using the same glue. In this way, I made a frame. In my living room, I have several and they look nice, so I thought it was a good idea. All that remained was painting it. I wanted a dark blue color and had blue and black paint at home. I thought of mixing them to make the blue darker, but one was water-based and the other was thinner-based. Despite the unusual mix, I painted it and was surprised by how good it turned out. The only thing I changed afterwards is the top wood. I ended up replacing it with a wood painted in a dark oak color. To finish, I varnished everything with a spray, and it ended up like this. I really loved how it turned out, nothing like how it was. But it's okay. This video is about the automatic bar, not about restoring refrigerators. So now came the whole issue of converting it. My idea was to have a tap or dispenser rise from the same table and pour the drinks into the same glass. How hard could it be? I began by creating the lifting mechanism for the dispenser, inspired by the mechanisms used in 3D printers. 2 metal rods with linear bearings and a motor are used. I printed supports for these rods, one to hold the rods and another for the bearings. It may not be clearly understood. The video clearly shows how they function. The rods are secured to the hillside by the printed piece, with 2 holes above. This setup ensures they are firmly attached. And on this rod slides the other piece with the linear bearings, which in turn also has 2 rods that pass through the refrigerator to the outside, with some bearings that also act as seals to prevent the cold from escaping. This bar is designed to work with 6 drinks at the same time, so 6 hoses should go up to the dispenser so that the drinks do not mix. But as they were too thick and took up too much space, I used only 4 hoses that I covered inside a shrinkable thermos for more firmness. In this way, we could use 6 different lives, but 2 of those should be able to mix with each other as they would share the same hose. For example, Fernet with Coke or gin with tonic water. That way they wouldn't look ugly. I ran the hoses through a hole in the refrigerator casing so that they are tightly fitted and not much cold escapes. But all of this had to be motorized, otherwise, what would be the point? I started with the dispenser itself. The cup would be to the right of my dispenser, so the dispenser should go up and then move to where the cup is. Otherwise, it would spill the liquid. For this, I put a 3500 printed base on top. Anchored to this base, I put a servo, which is a small rotating motor. Using a gear, I can transform it into linear movement. I printed this using PETG for good quality and flexibility. This way, the movement is upwards. The device then moved outward over the glass. To make it rise, I needed something stronger yet precise, so I used a 3500 printer stepper motor. Using a gear with a toothed belt, I tied this belt to the 3500 piece that raises the mechanism. So when the motor spins, it would raise or lower the system. But how do I know when to raise and lower it? I needed to put some type of sensor. I really like using these. They are magnetic sensors. That is, they detect when there is a magnet nearby. I simply put 2 of these and then strategically placed 2 magnets in the structure. So one sensor would detect when the mechanism is at its highest weight, since the magnet would pass right in front of it. The other sensor functions similarly when fully stored. An ESP32 Wi-Fi board was programmed to manage these systems and bar functions. Drink dispensing was incomplete, but hoses and 3D printed elbows were added to guide the drink into the glass without choking the hose. Pumps were needed to push the liquid. These pumps function differently from typical centrifugal pumps that require liquid to operate. These work even with air since they work like a compressor. Both the pumps and hoses are non-toxic and food safe. I used 6 pumps, 1 for each drink, and the board with 6 relays to be able to activate each of those separately. The operation is straightforward. We program the drink based on time. If it takes the pump 10 seconds to fill the glass and we want a drink with proportions of 70 and 30%, then we leave the first pump on for 7 seconds and the other for 3 seconds. Pretty simple, isn't it? Once nearly everything was done, I began arranging the cables. I didn't do too much, but I did place the electronic components as far away as possible from the hoses already, since liquids could spill and break the entire system. However, I wanted to take it a step further and enable Alexa to prepare drinks. I used a library called Faxmo for that. What it does is trick Alexa into simulating that our Wi-Fi board is actually a Philips smart lamp. So we can tell Alexa to set our lamp, let's say, to 50%. And this command reaches our board, so I set it. Let's say when I say to set the lamp to 60%, it prepares a Fernet for me and that's it. But it's boring to tell Alexa, set my light to 60%. So I created a routine in Alexa that is, when I say to prepare a Fernet, then set my lamp to 60%. And so I could directly tell Alexa to prepare the Fernet for me. A simple and effective trick. Going back to the fridge, I cut into the wood where the dispenser would come out and nailed the wood to the fridge. Now, to simulate a huge hole that doesn't look good at all, what I did was put a coaster over the hole. Several of these would be on the table to avoid looking strange. I put 2 more next to it and made a border with 3500 printing that even looks a little nicer. The idea is that when I talk to Alexa, the coaster lifts up and my dispenser comes out, and well, after a lot of testing, it ended up like this. Alexa, prepare me a Fernet. Very well. On Instagram, I will be showing more drinks and combinations. Don't forget to follow me. Thank you for watching my video and see you in the next one, which will be very soon. Bye. Should it be an ice dispenser?